Proving a triangle is equilateral. If it is an equilateral triangle, all the lengths of the triangle will be equivalent. The formula for this is L squared equals x2 plus x1 squared plus y2 plus y1 squared. You will plug in the following points for side FG: negative 5.16, 7.41, negative 1.80, 1.45. Make sure to square root the final answer. You do the same thing for side EG and side EF. You will plug in the points given and then plug it into the formula. After solving for the lengths, the triangle will look as the one shown. The next step is finding the midpoint. The midpoint formula is x2 plus x1 divided by 2, y2 plus y1 divided by 2. For side FG, you will plug in the following points. Notice that the points are the same points that we had used for the length formula. The midpoint will be found by using the formula. For side EG, you follow the same steps as you would have for the side before. For side EF, you also follow the same steps to get the midpoint. Midpoint is an important part of the triangle. Now you will find the right bisector. First step is to find the midpoint. Second step, find the slope. Third step, find the reciprocal. Fourth step, build an equation. And 5, connect to the opposite vertex of the triangle. The work that we just did solves for the midpoint shown below. Now you find the slope. The change in y over the change in x equals y2 minus 1 divided by x2 minus x1. Plug in the following points as previously given into the formula as shown. You will find the slope, and then you need to also find the reciprocal. You will follow the same steps for EG. You also follow the same steps for slope EF. Now you're given the equation since you've found the slopes of each side. With the equations, you are able to build right bisectors, as shown in the figure, by connecting the midpoint to the opposite vertex and using the reciprocal for the line that connects to the opposite vertex going through the midpoint. Now to find altitudes. The altitude is more commonly known as the height. To find the altitude, you do the base times the height. Find the midpoint of each base and then connect it to the opposite vertex. An altitude is also a line which passes through a vertex of a triangle and is at the right angle to the opposite side. A triangle has 3 altitudes. They all pass through the orthocenter, but the orthocenter is not always in the triangle. Find the orthocenter by using substitution or elimination. The medians. Connect from the midpoint to the opposite vertex. A median of a triangle is a line segment from a vertex of the triangle to the midpoint of the side opposite the vertex. Because there are 3 vertices, there are of course 3 possible medians. The medians are as followed. Notice that they have the same information as the altitudes. The medians, an interesting fact about them is that no matter what shape the triangle is, all 3 always intersect at a single point. This point is called the centroid. Each median divides into a triangle 2 smaller triangles with the same area. 3 medians divide into 6 smaller triangles and will have the same area no matter what the shape. Notice that the triangle is the same as the one shown before. As you can tell, the right bisector, medians, altitudes all intersect at the same point. The centroid, orthocenter, and circumcenter all lie in the same position. This is how you're able to tell a triangle is truly equilateral. Now, using technology today, I'm going to show you how to construct an equilateral triangle using GSP. On GSP, you're going to create 2 circles and you're going to make a line from E to G because you have found the radiuses. You're able to create a third radius, which is point F, because of the two circles. Once you've created all your points, you're able to hide the segments of the circles as shown. Now, what you want to do is solve for the length. You're able to highlight length on each one, as shown, and you are given the length. Now you want to solve for the angles. What you do is you highlight each of the points, E, G, and F, but in order as the vertices follow, and you're able to measure the angle. Follow the same repeated steps, highlighting the vertice next, all in order, and you will figure out that all the angles of an equilateral triangle are 60 degrees. The next step, after finding all the angles, is to try and start to calculate the midpoint. You'll highlight each line segment, E to F, click Construct, and go to Midpoint. Segment F to G, click Construct, go to Midpoint, and segment E to G, click Construct, and go to Midpoint. The midpoints are important because for all right bisectors, medians, and altitudes, this is where the lines connect and pass through to the opposite vertice. Now remember, we must also find the slope. You'll highlight the line segment, choose slope for each of the following sides, F to G, G to E, and E to F. Once given the slopes, remember that we will form them into negative reciprocals as shown before. And this will help us to create the line that passes through the midpoint to the opposite vertex to give us the right bisectors, medians, and altitudes of an equilateral triangle. It is interesting to see that in an equilateral triangle, all the lines meet at one certain point, and that point represents the circumcenter, orthocenter, and centroid of an equilateral triangle. This is how it is easy to prove that a triangle is equilateral. Make sure to highlight the point in the middle, which will be labeled point H, and this will give you the coordinates for your orthocenter, circumcenter, and centroid of an equilateral triangle.